Alright, so today we're talking about problems where the answer is positive or negative infinity. So, this is going to happen at vertical asymptotes. Your vertical asymptote, your definition is that if your limit as x approaches c from the right of f of x equals positive or negative infinity, or the limit as x approaches c from the left of f of x equals positive or negative infinity, then x equals c is a vertical asymptote of f of x. So if you have a vertical line, and as you get closer and closer and closer to that value, you either go up to infinity or down to negative infinity, that is a vertical asymptote. It can be from both sides. It can be from just one side. They can go opposite directions. They could go the same direction, or it could just be like one-sided, like natural log is an example of a vertical asymptote that you only have one side. There, it's still a vertical asymptote. We have already learned about how to find, oh gosh, what's happening? My pen turned on, that's the problem. Okay, we have already learned about how to find vertical asymptotes. Although, why is there not a function there? There was supposed to be one. Oh, I took it off and then ignore that. So, we are in general looking for any value that causes the denominator of a simplified function to equal 0. So, once it's been simplified, if the denominator still equals 0, then that's your vertical asymptote. The simplified part is because if you have things on top and bottom that cancel out and simplify, what have you got at that point? You've got a hole in the graph. If we're asked to find a vertical asymptote for something like example 1, we're just looking denominator equal to 0. Will this one simplify any? It will not. So we are just going to have the denominator equal to 0. We will get x equals negative 2 for that. Some of your assignment tonight is just going to be finding vertical asymptotes. We've already done a little bit of that. It doesn't, because like if I included it like this, like looking at the whole denominator being 0, since it's just a number, I would just divide off that 3 and I'd still get x plus 2 equals 0. And then I'd move that over and get x equals negative 2. So if it's just a coefficient, it does not affect the vertical asymptote. Now, if I had something like this, if I had 3x times x plus 2, where would the vertical asymptotes of that be? It would be at 0 and at negative 2. Because if I have something like 3x, that's an expression with a variable, and I have to think of what would make 3x 0, and what would x plus 2 be 0. But if it's just a coefficient, it doesn't affect the value. Okay. For number 2, I would need to, well, you technically don't have to factor. You could just think about what makes this equal 0, or you can factor. You can do it either way. If I'm just solving this, I'll get x squared equals 4. I will square root both sides. What will I get when I square root both sides? Plus or minus 2, because when I square root both sides, I've got to put the plus or minus with it. Or you can do it this way, where you've got x minus 2, x plus 2 in that denominator. Will the numerator factor? It will not, because it's got a plus sign. So it just stays the same, and you won't have anything that cancels. So both positive 2 and negative 2 are your vertical asymptotes for these. They may do it either way. They may list them separate. They may just use the plus or minus 2. As far as free response goes, either one would be acceptable for that. Okay? Questions? All right, let's move on. Ooh, look at this one. some trig. We always love to see it show up. And we still just want to think about denominator equal to 0. If this was sine or cosine, we'd just say none. Sine and cosine are continuous. They don't have vertical asymptotes. But all the other trig functions have vertical asymptotes. They are going to have vertical asymptotes when the denominator of the function equals 0. So currently, it doesn't look like there is a denominator. But how could I rewrite cotangent? Cosine over sine. So I could make this cosine of pi x over sine of pi x. So I'm thinking about where does sine of pi x equal 0. That's where I'm going to have vertical asymptotes, right? So I first have to think about where sine equals 0. So sine is your y coordinate. So it is at this point right here where you get 1, 0. And this point right here where you get negative 1, 0. What are the values? What's the value right here at 1, 0? What's your angle right there? It's 0 radians. You could also say 2 pi, right? That would also work. Now, careful with this because I got sine of pi x. So like essentially what you're doing is you're doing like sine inverse. We're saying where sine inverse means where does sine equal 0. So we're getting pi times x equals 0. We also would get pi times x equals pi. If we wanted to, we could get pi times x equals 2 pi or pi times x equals 3 pi or so on. All right, these are infinites here if they don't restrict it to a domain. So I've not solved for the x yet because I still have this pi right beside of it. So if I divide by pi, on this one, I just get 0. But over here, what is pi divided by pi? 1. And then if I think about doing like the next pi x equals 2 pi, x would equal 2. How would I give this as an answer? So I've got vertical asymptotes at where? At k. At x equals k. And what do I have to say that k is? K is an integer. There. So you've got vertical asymptotes at x equals 0, x equals 1, x equals 2, x equals 3, x equals 4, and so on. Also for the negative direction, x equals negative 1, x equals negative 2, and so on. Those can be the trickiest to do, those trig ones. There. We should be pros at doing number 4. What should we do for number 4? We're going to factor top and bottom. So we'll have x plus 4, x minus 2 on the top. The bottom is going to factor into x plus 2, x minus 2. So if the question was asking for discontinuities, I have them at 2 and negative 2. But are they both vertical asymptotes? They are not, because this one cancels out. So I only have a vertical asymptote at x equals negative 2. So we've really already done some of this. You've already had homework on a lot of this. But the reason that we're going back over it here is because you're going to get infinity or negative infinity for your answer anywhere that you have a vertical asymptote. So here in this blank, limits occur at vertical asymptotes. So whenever we are asked to do something like the limit as x approaches 1 from the left of x squared minus 3x over x minus 1. I'm looking at the limit as x approaches 1 from the left. What do I have at x equals 1. Vertical asymptote. Because the numerator here, if I do try to factor it, it would be just the greatest common factor, x times x minus 3. Does anything cancel? No. So I have a vertical asymptote here. So a few things to note. If I tried direct substitution on this, so if I tried direct substitution, I would have 1 squared minus 3 times 1 over 1 minus 1, which would give me 1 minus 3 over 0. So negative 2 over 0. What does that tell me about this limit? The limit does not exist. Now, that might be good enough, but a lot of times this is going to be a multiple choice question, and you look down at your answer choices, and the limit does not exist, is not there. What is there is positive infinity and negative infinity, right? We got to know, like, I know it doesn't exist because this is a vertical asymptote. I know that because it's a vertical asymptote, I know it's going to be positive infinity or negative infinity, but I don't know which one. So, if you see something like this without a calculator, then our options are kind of slim here. That is only for x approaches infinity. So that'll tell us our horizontal asymptote, but that really doesn't matter at 1 because we're not looking at infinity. So we can't do like Bobo-Botno for this. So, and be careful with that because I have had students, like when we get to the test for this, they Bobo-Botno everything because it was like the most recent thing that we did. And so they're Bobo-Botnoing x approaches 0, x approaches 5. They're missing everything except for the x approaches infinity. So watch out for that. Bobo-Botno only works if x is approaching infinity or negative infinity. So here, my only real way of knowing this is to like plug in some numbers and see, unless you really have a good picture of what this looks like. However, I'm not going to say I've got a great picture of what something this complicated looks like. So you're approaching 1 from the left. So I would maybe start, you know, like on the number line here, we're approaching 1 from the left. So you got 0, negative 1, negative 2. I'd probably start with like negative 1 maybe. So if I do negative 1 squared minus 3 times negative 1 over negative 1 minus 1, that is going to give me 1 plus 3 over negative 2. So 4 over negative 2, that'll give me negative 2. So I'm going to keep myself a table over here. X, f of x. I'm getting, when I plugged in negative 1, I got negative 2. Alright, let's try 0. 0 squared minus 3 times 0 over 0 minus 1. That's going to be 0 over negative 1. That's 0. So when I plug in 0, I got 0. Now I've increased here, but I probably need to go at least a little bit closer to this to know for sure. I would do fractions. I would not do decimals. Because if this were calculator active, you could just graph it and look. And you'll see some of these calculator active. So you'll be able to do that. But if it's calculator inactive and you're having to do like a table by hand, I'd probably go with 1/2 next. So you're doing 1/2 squared minus 3 times 1/2 over 1/2 minus 1. So this is some fraction practice here. You got to really dig deep for this back into your 5th, 4th, 5th, 6th grade brain and remember what to do. When I square a fraction, what do? Square the top, square the bottom. I'll get 1/4. Right here, that's like 3 over 1 to multiply fractions. Just multiply straight across. I got 3/2 over I'm going to leave this 1/2 minus 1 for right now. To subtract fractions, you have to have common denominators. So that's going to be 1/4 minus 6/4 divided by 1/2 minus 2/2. So that's going to give me -5/4 over -1/2. Dividing fractions is easy as pie. Flip the second and multiply. I dropped my negatives because negative divided by negative is going to give me a positive in this case. Oh, yes, I did not flip. Sorry about that. And so I'm getting 10/4 or 5/2 or 2.5, however you want to write that. So, what does it appear is happening here? Looks like we're increasing here. We're going to call that good enough for what we're doing right here because we're having to do this by hand. So you won't have many of these where you've got to look at them by hand. So since we're increasing and we're at a vertical asymptote, we should see that keep happening, and we are going to get infinity for our answer. It's kind of a pain for this, but it's not necessarily super. Nothing about the calculus is difficult. It's the calculations that are a little tough. Okay, questions there? So a few properties of limits for us to know. If we have the limit as x approaches c of f of x, if we know that it equals infinity or negative infinity, but I just wrote these rules for positive infinity to keep from it being too cumbersome there. And then we also know that the limit as x approaches c of g of x equals L. L here is just a number, any number. So if I am adding or subtracting here, then if I have f of x, which I know is infinity, plus g of x, which is a number, I'm getting infinity plus a number. But that's like whenever Buzz Lightyear says to infinity and beyond. Beyond infinity is still infinity, right? So it's a really silly statement that he says whenever he does that. But you just get infinity for that. Now, if you were subtracting the infinity, it would be negative infinity. You pay attention to your signs. So like if you're getting L minus infinity, because it's a negative infinity, you get negative there. Infinity minus L would still be infinity for that, because even if L is a very large number, it's nothing compared to infinity. So infinity sort of still wins out there. For the second property that we have, it's your product property. So if you have a limit where you're multiplying infinity times a value, it depends on the sign here of your L. Because if L is less than 0, that means I've got a negative number times infinity. Now that does change infinity, because a negative times positive infinity is going to give you negative infinity. Okay, so if your value is negative, you'll get a negative there. But if L is positive, infinity times a positive number is still just infinity there. They cancel and you'll get a positive, yes, for that. And then your quotient rule, if you have g of x, which is the one that is like our L right here, right? This is our limit, it's L. And then we have infinity on the bottom. This is one of those things like you don't want to write 5 divided by infinity. That's not really correct to write. But if we have 5 over something that's getting larger and larger and larger and larger and larger, then that is 0, right? That's very similar to what we were talking about yesterday. Anytime you have that happen, it's going to give you a 0 for that.
And the flip would just be infinity, right?
Yes. Well, yes. As long as g does not equal 0, and then you get like a weird indeterminate form, but I don't think they throw that at us in this class. The only indeterminate they should give you is 0 over 0 or infinity over infinity. So they won't give you like infinity over 0. That is indeterminate, but it's not something we have to deal with here. Okay, so sometimes whenever you get these problems, you can sort of break them down into different pieces so you don't have to look at the thing as a whole for that. So whenever you're looking at number 6, in my mind, I would be thinking about doing the limit as x approaches 0 of 1 plus the limit as x approaches 0 of 1 over x squared. Now this first part is very easy because the limit as x approaches 0 of 1 is just 1. If we have a constant, it's just that value. Now here, especially if this is calculator inactive, it's a little tougher because I have a vertical asymptote at 0, right? So I'm either going to get positive or negative infinity here. I need to know which one. I'm doing all these on these notes like you don't have a calculator because it makes it a lot easier if you do have a calculator. Like if I have a calculator, then all I've got to do is go over here to Desmos. I'm just going to open up my Desmos. I'm going to type in 1 over x squared. I'm going to see at 0, what does it look like I'm approaching there on both sides? Positive infinity, so I should get a positive infinity for this. So some of the ones you're going to have on your homework, I'm going to tell you you can use the calculator on. So just graph it and see what it looks like much faster. But let's say that we don't have that here. Where did my notes go? Right here. Mm-hmm.
Do you think about it as like, as you get like a smaller and smaller decimal being squared, that it makes it a bigger number?
Yes. Yes. Because like as you have numbers that you plug in here, what's going to happen, and I really don't have time because we're about out of time here. What's going to happen is you're just going to see that you've got a decimal on the bottom, and when you divide by a decimal, it makes the number bigger. So these numbers get bigger and bigger and bigger. So it's infinity. What is 1 plus infinity? It is infinity. I don't have time to do 7, but you can do the top of 7 and the bottom of 7 separately. The top is going to give you a number. The bottom is going to give you either positive or negative infinity because there's a vertical asymptote. Does it even really matter? Like when I plug in -2 here, I'm going to get 5. On the bottom, does it really matter whether it's plus or minus infinity? Not really, right? Because what does that equal either way? 0 for that. Because if you got a giant number on the bottom, it's going to be 0. So on the assignment for this, 13 through 25 odd, these are finding vertical asymptotes. They should be quick, right? The most you should have to do is like factor there. 37 through 47, I want you to try these without a calculator where you're trying to like figure those out in your head. 49 through 59, you can use Desmos to graph to see what's happening there, okay? So the only ones that should take much time should be those middle ones there. And if you get desperate, just type them in and look at them. And that's the last slide there. It goes to 59, so make sure you take a picture of a couple pages there.